Okay, so linear programming is a real-world application of a linear inequality system. So you have to, first thing you have to do is write the system, the equations, then you have to graph it, then you have to find the vertices, which we've been doing, and then you'll have to maximize and minimize. Okay? Most of the time we're working in maximizing profit, that's good, right, for your business, minimizing costs, finding the best investment strategies. I think one of the problems you have to do is optimize how much food you're going to feed the dogs if you're in a dog kennel. Okay, so we're applying this knowledge here. The nice thing is, if you can write the equations properly, it pretty much falls out. Okay, that's the hardest part, is writing the equations. So I'll give you kind of a system to go through it, and I think we'll be okay. Would you rather see a manufacturing or a small business application? Okay. Now, I'll write this whole problem out so you see it in real time. Okay, so it's going to take a few minutes here, but we have a lumber mill. Can turn out 600 units. Of product each week. We're going through this. Think, what do I need mathematically? Okay, well, I'm starting to notice things already. Okay. We're looking for numbers and add, subtract, multiply, divide, basically. To meet the needs of its customers, the mill must produce $150 lumber units and 225 units of plywood. So again, I'm seeing mathematical items coming through here, right? With the profit for each unit, of lumber is $30, and plywood is $45. How much of each type of product should the mill use to maximize profit? No. Woo! Yeah, they're long, wordy problems. first thing you have to do is define your variables. This comes usually in the question part. So what are my variables going to be? If you're looking at the question that you're actually asked, how much of each product should the milk produce to maximize profit? What aspect of it? How much it costs? How much we're going to make? So that right there tells you what your variables need to be. How much of each product? Because you can define X as number of units of lumber and Y as number of units of plywood. Now we're going to write our equations for inequalities, really. What are some things that we see that we can use mathematically? How could I write that as an inequality? We can turn out up to 600 units. Yeah. 600 is the maximum. How do I use X and Y to get 600? Yeah, just X plus Y in this case. We have an equation. X plus Y is less than or equal to 600. If you need to in your answers, you can write all over these problems. Circle, underline, line, whatever. Okay. All right, we need a couple more pieces of information. The mill must produce 150 units of lumber. No, see, now that's I'm glad you said that. This is 150 units, and this is number of units. Okay, can we multiply those together? No, we can't. But we can set them equal to or unequal to each other, right? Because they're both units and units. So there. The units and the units, they have to be some way related across the side. And then what would the other one be? Yeah. Defining your variables helps you know that you can't do 150x. That's our system. Now we can graph it. So let's go ahead and graph that. Most of the time, I'm never going to guarantee all the time, we're going to be floating around in quadrant 1 as money and costs and all this stuff we want to all be positive, times positive. So usually we can just worry about quadrant 1. The x-axis scaling. This goes to 150, right? What is the x-intercept, though, of this equation? Plug 0 in for y. What do you get the x-intercept? 600, yeah. So we need to go all the way to 600 here. Because we need that equation to get both axes. So I'm going to go by 50s. And we know that that equation is the x-intercept and the y-intercept is also 600, right? Now I can draw that. I'm going to hold off on shading this, but I would shade below it, correct? Good with that. Now let's draw this 150 here. And then 225 right here. And then where's my shading going to be? Yeah, it will be less than this line. So down here, greater than this line, and greater than this line. So it's in here. Usually you're going to get a polygon of some kind, triangle or a quadrilateral, something. That's the goal. Okay, that was step 3. See how these problems can get kind of long? Yeah, they can be kind of painful. Now, the vertices. You've heard this vocab, right? Feasible region. Right? Okay. So we're looking at those 3 edges. What are they? Yeah, this one's pretty easy, right? The x and the y. What's that one? Well, if the x is 150. Plug it in, what's the y value? Negative 150 plus 600. And this one, y is 225. I heard somebody say. That means the x is 275. You're guaranteed, there's a little mathematical theorem, that these will be your maximum or minimum points. You don't have to worry about any others. So a little star there. They will be your maximum rating. So we don't have to worry about anything else in the shading or nothing. Just the colors. One more step. Are you with me? Like I said, it's kind of long. One problem takes me 15 minutes to show you. Alright. We have to write a profit function. If the profit for each unit is 30 for lumber and plywood is 45, what would our profit function be? This is how you're usually going to see it in our book. I agree. $30 for lumber plus 45 for plywood. They're usually that straightforward. Anybody guess what the next step is? This is why the maximization from the last couple days. Just kind of give you a little practice there. So, honestly, do you think this point's going to be the best? It's not, because these have bigger numbers, right? More money. So, you can just say, I'm not even going to test that because it's very obvious it's going to be less money. Okay. What's the profit for that? Plug them in for X and Y. This is very calculated, it's pretty handy. That's 4,500. Go ahead and calculate the other one. 375 and 225. I can predict it's going to be a loser. There is our maximum profit. So your answer would be the mill should produce 150 units of lumber and 450 units of plywood. That's the final statement. You get in the job and you have to do something like this, they're going to want to know that statement right there. They don't necessarily see all this probably, but that's what they're going to want to know. You can't just throw this at them. Okay. So, this must be a really small lumber now. Any questions? The sheet I have for you today has tables on it. So I didn't.
I didn't put a table together here. But one way to solve these problems is to put all of your info in a table. So when we define our variables, these are going to be this is on the fly here, so yeah, this will work. And then we can go through and if we're looking at the problem, we're thinking I have a total here and I have a couple of individual measurements. So all those. See how the table might help you build your equation if you want to use it. The sheet I have today has the tables on them. You just fill it in. And then we would have X, 150, Y, 25. And you can write your equation. So this is something that helps some people it doesn't. So if you need to use it, have at it. But they're provided for you today. Okay, so we've given them to you today, so you can use them. Tomorrow I will take the tables away and you have to write them yourself. And that three if you want them. Yes, that's right. I counted three. I can count to 4. Done that before. I say whatever therapy they okay. Number 2. So just one note. For some reason, I remember number 2 being screwy. I don't know why. I couldn't pinpoint it this morning in the 5 minutes I was looking at it. So I just wanted to cross it out. Okay, don't worry about doing number 2. It's just the 6th sense, like I said. I'm looking at the table and reading the problem because it's funny. So 1, 3, and 4. And then try 6. Okay, number 6. Let's do that. 1, 3, 4, and 6. Yay. And then we should be good. So hopefully you got time to finish number 1 right now. If you have any questions on it, I can get you some individual help, okay?